A, B, C, D. Make sure we label it clockwise, counterclockwise. I'm going to draw in A, C, and B, D. What do I call those right there? A, C, and B, D, just to make sure we're good. Start this off right. Jonathan, A, C, and B, D. I just drew in what? Diagonals. Thank you. They intersect at P. So if you don't know our properties, all right, make sure we know them by Tuesday, right, for the unit test. Take a look at your paper in the middle of your desk right now before I ask this for somebody. PAP 7x minus 10 and PC 9x minus 30. And it's telling me all of BD 10x plus 20. Tell me something about the diagonals so I can do something with these. Okay, diagonals of a parallelogram. Now remember, this is a parallelogram. Okay, don't look here in a square. So diagonals congruent, that's out. All right, diagonals perpendicular, that's out. All we know is this bad boy is a parallelogram. So diagonals of a parallelogram. What do we know about them? So I can do something here with these numbers. Diagonals of a parallelogram. Where am I going with that, Halo? Bisect each other. So that allows me to set 7x minus 10 equal to 9x minus 30. Okay, that's the only reason why I can do that. Diagonals of a parallelogram bisect each other. You solve it. X equals 10. Okay. Now, what type of parallelogram is it? Is it a rectangle? Is it a rhombus? Or is it a square? Well, I'm not going to know until I plug it back in. So I take X, plug it back in. Let's do AP first. 7 times 10 minus 10. AP is going to be a length of 60. PC, I already know what it should be because they bisect each other, but let's just plug it in already. 9 times 10 minus 30. Oh, shocker. Also comes out to be 60, which it should. Diagonals bisect each other. But then what about the other diagonal, BD? What about the other diagonal, BD, which was 10x plus 20? Here you go. Ready? 10 times 10 plus 20. That's going to give me a $1.20. So what do I notice about diagonal AC and diagonal BD there? What do I know about those two diagonals from plugging in 10 there? Diagonal AC, those two diagonals, what do we notice about them? 1-7, Alex, what do we notice about them? This piece was 60. This piece was 60. BD was 120. What do I notice about the diagonals? Okay, let me go a little further. 60 and 60 gives me how much? 120. So this whole diagonal is 120. BD is 120. What do I know about the two now? They're congruent. All right, so if you got to look on your paper now, go look on your paper. I have a parallelogram with congruent diagonals. What do I have? Definitely got to be a what? All right, I have a parallelogram with congruent diagonals. That only happens in one figure. Parallelogram, congruent diagonals. This might be, probably is, T, a rectangle. Now, some of you might want to say a square. I get it, but I don't have enough information to say it's a square yet. All right, parallelogram with congruent diagonals makes this a rectangle. Not enough information to say it's a square yet. Not enough. I still need a little more, but I can at least say it's a rectangle. Questions there? All right, you guys have all the information. I'm not doing any more figures. You have everything you need. Parallelogram, rhombus, rectangle, square, trapezoid, isosceles trapezoid. You guys have all the properties. It's just a matter of when you feel like studying them, all right, to get ready for Tuesday. All I'm doing today with you, going over a couple more these coordinate proofs. Slope, midpoint, distance. So make sure we know, I don't want to review them again. Make sure you have those formulas wherever you need them. All right, so why don't we do this right now? Why don't we add to our property sheet in the middle of your group right now, midpoint, distance, and slope. Well, go ahead, I'll give you about 3 minutes right now to write them down on the sheet of paper. All right, so we're not flipping back and forth, back and forth, back and forth for those formulas. All right, so somebody take charge, add to the group, please. Slope, midpoint, distance formula. Add to your paper right now. These will not be, as you write them down on your paper, these will not be given to you on Tuesday's test. Okay, they will not be given to you on Tuesday's test. You are responsible for these 3 formulas. Once you have those formulas, go ahead and graph vertices of triangle PAT. So make sure you have those 3 formulas and go ahead and graph part A. I graphed it wrong, I think. No, I graphed it wrong. Got all the formulas, looks good. Most of the groups do. All right, go ahead. I'll give you another minute to graph PA and PAT. And then we'll talk about what it's asking you to do here in part A. All right, looks like we're good to go. All right, first part, part A. Let's prove this bad boy. PAT is an isosceles triangle. Talk to me, isosceles triangle. What's so special about them? So I can go somewhere here. Hayden, what do you know about an isosceles triangle? 2 sides are congruent. I also know 2 angles are congruent, but that's going to be tough to prove here. So I know 2 sides are congruent. This is the great thing about graphing. We probably know which 2 sides it's going to be. All right, you got 3 formulas written down on your paper. Which one's going to be the best for me to use to show 2 sides are congruent up here? True, Jesse. Which formula? Slope will tell me parallel. I want to know 2 sides are the same length. Distance formula. All right, and it's probably going to be on PA and AT. Everyone is probably on PA and AT. So I'm going to do the distance of PA, and then we're going to do the distance of AT. And hopefully when I plug them into my calculator, they're going to be the same. All right, so use your distance formula. X's, hopefully you guys agreed and it's all correct. Subtract your X's in any order. Let's see, PA, -4 minus a -1, -6 minus 5. Square root of 130. All right, hopefully you're getting both to be square root of 130 right on your calculator, and that's what we wanted. I know we've had a lot of time off here for the break, but second step in these coordinate proofs, tell me what you just learned. All right, what did we just learn in step one by doing the distances? What did we learn about those two sides right there? Where am I going with this one? Try again. That's where I'm going. Jesse, what did we just learn? They're congruent. So PA congruent to AT. Because how'd you know they were congruent, Jesse?
They have the same distance.
Distances are equal. Perfect. So if I know PA and AT are congruent, this makes it an triangle PAT is an isosceles triangle. Just tell me why now. How do we know? How do we know it's isosceles? What did we just show? Hayden, back to you.
Two sides.
Yep. There's two sides are congruent. Questions proving it's isosceles before we get to the main part. All right, don't start a new proof. We're just going to go step 4 or 5. Read through part B now. Read through part B. Give me point R now. Point R so it becomes a parallelogram. Whew. Give me point R so it becomes a parallelogram. We know it's got to be PAR. So RA, look up, R's got to be somewhere over here, right? Because it's got to go in that clockwise, counterclockwise order. Well, if it's going to be a parallelogram, and if you got to look at your sheet, look at your sheet. What do I know about opposite sides? Talk to me. Opposite sides of a parallelogram. There's a couple things, but I'm looking for one in particular. Opposite sides of a parallelogram, so I can help you guys out here. Taylor? They're parallel. All right. They also are congruent. I would have taken that too, but I'm really looking at their parallel here because if they're parallel, opposite sides, then if they're parallel, should have the same what formula? Slopes. And that's what we're going to do here. So look at the slope of PT right now. Go up and over for me. Up and over. Tell me what the slope of PT is. Up and over how many? Rise over run. Up and over how many? Taylor, back to you when you have that. 4 over
5.
I have 6. 4 over 6. Okay, so you just missed one. 4 over 6. Hey, that's got to match AR. If that's 4 over 6, wherever A and I'm going to place R has to be 4 over 6 too. So I'm going to go to point A and go what? Match it. Go up how many? 4 and go over 6. And I'm guaranteed that that's going to have a slope of 4, 6 as well. So from point A, I'm going to go up 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6. Got to be there. All right, there's my point R. And the only thing left I need to do is name it, which is, let's see, what's that? 2, 9. So point R is 2, 9. Everyone all right on how I, because I might ask that on Tuesday. That's a good above average quadrilateral question right there. Opposite sides have to be parallel, so I got to match their slopes. Now, by the way, could I have just done it on AP and done it with TR? I could have, but PT was a little smaller, so that's why I chose to do it. All right, show me it's a parallelogram now. Part C, show me it's a parallelogram. We've done a lot of the work, haven't we? Do I really want to show opposite sides congruent? Probably not. I already know the slope of PT and AR, so let's show opposite sides are parallel instead. We've already done two of the slopes already, right? We already know PT equals 4, 6. And we already know AR equals 4, 6. So let's work smarter, not harder. Or harder, yeah, let's work smarter, not harder. Now the only thing I need to do is do the slope of PA and TR now. Just makes sense doing it this way because I've already done 2 of the slopes. So go ahead, find the slope of AP and find the slope of TR. Where'd you find the slope of both of them to be when you have it? Taylor, 3 for 3 here when you have it. Redeem yourself on your counting.
Yes, 10 over 3, unless I can't count still.
I don't know, maybe I had 11.
Well, I had that, and then I just recounted and I got it wrong. I got to
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're right, though. Trust your gut. 11 over 3.
Yeah.
But take a look.
It's, well, if we're going from A to P, it would be negative.
Correct. Yep. Negative because it's going downhill there. So negative 11 thirds for both. All right, next up, anytime you use a formula, what did we just learn? Right, anytime you use slope, midpoint, distance, what did we just learn about those sides going up there? Those sides, Juliana, what did we just learn? They are parallel. So PT, parallel to AR, and AP, parallel to TR. Why'd you say they were parallel, Juliana? Because slopes are equal. Nice. And if the lines are parallel, what type of figure is this now? Opposite sides are parallel. This must be, Hayden, parallelogram. PART is a parallelogram because, how do you know it's a parallelogram, Hayden? What did we just show?
Slopes are congruent and both sides are parallel.
Okay, you can just say opposite sides parallel. Yep. Done. Good work, everybody. Good work. We're going to skip over 2. I'm going to save that for tomorrow's class because I want you guys to start reviewing here in a minute. So we're going to go to number 3. All right, number 2 we'll do tomorrow first thing. So we're going to go to number 3. And go ahead and graph that triangle for me. Just make sure you label your vertices. Throw A, B, and C on there for me, please. All right, prove it's a right triangle. All right, well, if it's a right triangle, it's got to have a what? It's got to have a right angle somewhere. So we need to show this bad boy's got a right. Can we kind of guess where it's going to be? Probably where? What angle? Probably angle B. Okay, so we know that. How are we going to show there's a right angle there at B? Well, how are right angles formed in this class anyway? AB and BC have to be what to each other if that's going to be a right angle? Perpendicular. All right, let's keep rolling. Good discussion. Let's keep rolling. So if they're going to be perpendicular, what formula are we going to need to show they're perpendicular? Oh. If AB and BC are going to be perpendicular, we're going to need one of those 3 formulas you have on your paper. I'm going to need Slopes. Negative reciprocals. Show the slopes are negative reciprocals. All right, that's what I'm going to need for this one. Show AB and the slope of BC are negative reciprocals. So let's start with AB, because something weird's going to happen here, and I just want to make sure you don't get worried if this ever happens to you. So let's find the slope of AB first. Up and over how many for AB? Up and over how many there? There we go. Rowan, what's good? Up and over how many? Something going on with the counting here in this year? Is this like the new 2025 trend? Is everyone all right? You want to do that again? Did you graph them right there, Rowan?
No.
All right. Is this like I don't know? Is that like I'm getting like pranked or something today? Like this is the new TikTok trend or something? Get your math teacher going. What do you got now? 3 over 3. I'm just going to put 1, right? 3 over 3 is 1. All right. Now let's do it for BC. Slope of BC. Up and over how many for BC? Jackson?
Oh, negative 2 over 2.
Oh, there we go. Negative 2 over 2, also known as negative 1, right? All right, now we look at these. Now, some of us may say not negative reciprocals, so we have a problem, but they are. If you take 1 over 1, flip it, and change the sign, what's it become? If you take this, flip it, and change the sign from positive to negative, what does it become? Negative 1. So these are indeed negative reciprocals of each other. 1 and negative 1 are negative reciprocals, meaning, what do I know about A, B, and BC? They are perpendicular to each other. All right, 1 and negative 1 are negative reciprocals. So they're perpendicular because slopes are negative reciprocals. So if you ever see a 1 and a negative 1, they're negative reciprocals. All right, you guys have done a slew of proofs this year. If you know 2 lines are perpendicular, what do we usually tell me next? We have a what type of angle here? Right angle. Angle B is a right angle because what would we always put in the reasons column if we saw perpendicular, 2 perpendicular lines? Because there we go. Perpendicular lines form right angles. And if angle B is a right angle, guess what? This has to be a right triangle. So triangle ABC is a right triangle. And I'm just going to have somebody finish this off. How do we know this is a right triangle? What did we just show? Let's finish this off here. Maybe. Sydney, how do I know this is a right triangle? Because it has a right angle. That's it. So I might not ask you to show it's a parallelogram, rhombus, rectangle, right? We just did isosceles triangle earlier, now a right triangle. So I may not do a coordinate proof with the quadrilateral. So just a heads up there. Everyone see the assignment for tonight. That's all review. That is all review. Go to the next page for me, please. That's all your properties right there. Okay, a nice little chart with all your properties. And if you ever forget how to prove one of these on the coordinate proof, that's the next couple pages is how to prove. Okay, so all your properties are right there for you. In case you don't have that sheet that's in the middle of your group, all the properties are right there. And then page 54 is on the next page. All right, answer key. Please check your work. Answer key is in the back of the packet. Okay, so is everybody good? What's the assignment here for tonight? Page 54, which is a couple pages ahead. Those numbers, and then the answer key is in the back of the packet. All right, so please start knowing your properties now. All right, this is where we get a little bit better. The review starts now. Okay, review starts now.